Hello everyone, myself Priyanka and I welcome you all to my session. So let's just go through our question for today. Derive an expression for the electric field E due to the dipole of length 2a at a point distance r from the center of the dipole on the axial axis. Alright, let me tell you that this is one of the most important derivation from the topics electrostatics. So let's just go for it carefully, considering all the steps one by one. Okay, so before starting, first we have to pay importance to the diagram, of course. So let's just go for the diagram first. So we have to make the dipole. So let this be a dipole. Let the point O be the center of dipole. We have point A and point B. On point A, let us keep the charge minus Q, and on point B, let's keep the charge plus Q. As always, the distance between the two charges on the dipole is given by 2A. We have to find out the electric field intensity at point P, where a unit charge plus 1 is kept, and this point P is at a distance of r from the center of the dipole. So all this information is already given to us. Now, what we have to find out is the electric field intensity at this point P. Alright, so for that we have to find out the electric field because of the charge minus Q and because of the charge plus Q. So let E1 be the electric field intensity at point P due to minus Q charge. So see, this is positive charge at P and this is negative charge at A. So they're going to attract each other, because of which the electric field intensity is going to be in this direction. So it is going to be E1, that's a vector, and it is in this direction on the left hand side. So E1, we are just going to put in the formula of E1, which is equal to Q upon 4 pi epsilon naught AP the whole square. So that's just the formula of electric field that we are writing. So it is equal to Q upon 4 pi epsilon naught R plus A the whole square. And we're just putting the magnitude of E1 here. Therefore, we are not bothered about the sign of this charge Q. Talking about the electrical field E2, because of the charge placed at B, that is plus Q. So it's going to be in this direction. So this is going to be the direction of E2. So E2 is equal to Q upon 4 pi epsilon naught BP the whole square, which is equal to Q upon 4 pi epsilon naught R minus A the whole square. Now see, as we can look here that E1 and E2 are in the opposite direction, so the net E at point P is equal to E2 minus E1. E is going to be equal to E2 minus E1. Why E2 minus E1 and not E1 minus E2? That's because the magnitude of E2 is greater than E1. So because they are having direction, so we can just put in the vectors as well. So now simple mathematics, we just have to put in the values of E2 and E1 and find out the value of E. So it is equal to Q upon 4 pi epsilon naught 1 upon R minus A the whole square minus 1 upon R plus A the whole square. It is Q upon 4 pi epsilon naught. Let's just take the LCM, and then I'm opening the brackets as well, minus r square minus a square plus 2ra. That's just simple mathematics that we're supposed to do in here. R square minus a square the whole square. You can see that this r squares are getting cancelled and also this a square are getting cancelled. So it is q upon 4 pi epsilon naught 4ra upon r square minus a square and then the whole square for them. Now we can write it in the manner that we can easily represent it by dipole moment. So q into 2a into 2r. So what I've done is I've just split up this 4ra into 2a into 2r upon 4 pi epsilon naught r square minus a square the whole square. Now we know that this q into 2a is equal to p, that is the dipole moment. So we can write it as p into 2r upon 4 pi epsilon naught r square minus a square the whole square. Now we can also represent it by this, but then if we are considering that the dipole is small, that is if r is much greater than a, then what we can do is that we can neglect this a square in the denominator terms. So q into p into 2r upon 4 pi epsilon naught. We have just neglected this a entire term, so it will be r square into 2, that is it would be r to the power 4. So cancelling one power, it can be written as 2p upon 4 pi epsilon naught r cube. So point to note here is that this E is inversely proportional to 1 upon r cube. So that's the formula for your electrical field at point r because of this dipole on its axial axis. I hope I was able to make this derivation easy for you. Thank you so much for your time. Bye-bye.